Thank you so much for having introduced me. I am Andrea Marcucci, PhD student from Politecnico di Milano, and I'm presenting part of my research of my PhD program that is dealing with an extrusion-based system for additive manufacturing of fiber-reinforced concrete tunnel linings. Italy is a country with the country with the highest number of existing tunnels, the first in Europe, but the problem is that the largest part of these tunnels were built in the past. So in order to reduce the risk of their collapse, they need the strong maintenance intervention. What the company Infra is doing is to develop a new retrofitting technique based on extrusion of fiber-reinforced concrete. And this is a video that shows the process. Here you can see the placement of reinforcement that is it's an old video, so now we are wanting to use only steel fibers, but the steps consist on first scraping a first layer of concrete from the existing tunnels and then cast new fiber-reinforced concrete to fill the gap between the existing tunnels and the mold. And as you can see, it's an all-automated process. In order to improve the retrofitting technique, the company has also developed its own real-scale site that is made of rails, on top of which a steel frame can move back and forth. On top of the steel frame, there is an inner mold that has the shape of the tunnel, as you can see here, and there is also an outer mold that is simulating the existing tunnel. So the steel frame is moved just below the outer mold, and the concrete is casted from the key of the inner mold, and so the gap between the outer and the inner mold is filled with concrete. So the casting is from the key and concrete flows to the bottom. This is a video that shows the movement of the inner mold. As you can see, the velocity of the sliding of the mold is quite high. It's about 15 millimeters per second. And so far, in the real scale site, the length of each segment is about 1 meter. That is due to the capacity of the mixer. So we are dealing with an additive manufacturing technique, and as a matter of fact, concrete has to fulfill some material requirements that are the printability one that are made of pumpability. So concrete has to exhibit a very low yield stress at the very beginning in order to allow the pumping of concrete from the key to the bottom. So to cast properly the material, it has to be extruded, so the quality of the surface of the segments must be very good, and at the end, the last requirement is the buildability. That is due to the development of the strengths of concrete a long time, in order to allow the molding of the segments, as the segments must self-stand by themselves. So this is what I've just said. At the very beginning, the concrete must be very workable, with a reduced yield strength in order to allow the casting, and in order to improve the productivity of the maintenance intervention, concrete has also to exhibit a very fast setting in order to fulfill buildability in a short time. In fact, it is exactly what we got from the material point of view. This is the very beginning, so the material slumps a lot. The value of the slump is very high, and after some minutes, the material can self-stand, and this is, in fact, how the compressive strength of concrete increase over time. So just after 1 hour, around 8 megapascals are present for this type of concrete, and this is how we have decided to divide the very early age of concrete. So at the first 30 minutes, we are dealing with almost a fluid, so in order to characterize its properties, rheometer test can be done. After 30 up to 1 hour and a half, the material is still in its plastic state, but is developing strength. after which the material is almost in its solid state behavior. We have carried out two different experimental programs, a non-destructive one in order to assess the quality of the retrofitting technique, and then consists of tomographic inspection and a magnetic inspection that we have carried out on site. Then a destructive test, we have carried out some destructive tests on beams and cubes according to European code, and the tests were performed in the lab. And this is just a scheme of the tunnel segment of the site that has the height of about 5 meters, and this is where the site is. It's very close to Milano, so we went in a couple of days and we have done all the on-site tests. And these are the points at which we have took the measurement for every tunnel segment. So first non-destructive campaign was on tomographic survey, so with the use of a A1040 Mira 3D that is made of blocks of transducers, and every transducer has can work as an emitter and a receiver, so it to generate 8 scans from which it was possible then to generate some tomographic scan called XB scans. And if you apply in different points the tomograph, you can also build some volumetric scans, so you can detect an entire strip of, in this case, of the tunnel segments. Why we wanted to use tomographic survey? In order to look at the quality and the presence of defects or voids inside the tunnels. In particular, this is a scan of the interface between two adjacent segments, and we have seen that qualitatively the defects are not present here. This is the end of the width of the segment, so it's the external surface, and between the intrados and the extrados, no defects were observed, so it's like the two segments are welded together. And these are some of the results we have looked at different height of the tunnel, and we have seen that no defects were observed, as the material was homogeneous all over the tunnel. Then we have also carried out a magnetic inspection in order to study the dispersion of the fibers. This is the magnet that we have used. It's just a magnet inputted in the computer that gives you the value of inductance, and then we have found the relationship within the inductance measured by the magnet and the density of the fiber. So for each point of application of the magnet, you can define the fiber density in that point. Most important, the more the fiber are aligned with the magnet, and the higher is the value of inductance measured from the magnet. So for this reason, we have put the magnet on different orientation in order to see if the fibers were influenced by the casting direction. So these are some of the results, and we have seen that the fibers tend to be more present around the key of the tunnel, but for the orientation, this is 0, 45, 90, and 135 degrees. So 0 is the axis of the lining. And we were expecting that a higher distribution was found for the 90 degrees, that is the direction of the casting exactly. So, but we have seen that the distribution of the fiber was not influenced by the casting. So, dealing with the destructive tests, we have tested 6 beams and 6 cubes in order to develop the bending strength and the compressive strength with a fiber-reinforced concrete of 40 kg of cubic meter. These are the results of the compressive strength that we have seen very easily, that the class of concrete is about C45-55. And these are some of the results. These are the results of the bending strengths. In particular, during the test, you are monitoring the load and the crack opening displacement of the at the midspan of the specimens. Then you, from the load, you derive the stress, and these are the curves: stress, crack opening displacement. And according to the model code 2010, we have found the residual strengths at 0.5 millimeter of crack opening displacement and 2.5 millimeter of crack opening displacement in order to characterize the bending behavior of the beams. And this is the class that we have found. In fact, 6 is the characteristic value of the first residual strength, and E is the ratio, so 1.48. There is the ratio between the FR3 and the FR1 characteristic values. So we are dealing with a strain hardening material. In fact, the strength is increasing as you are increasing the load. So from the compressive strengths and the bending strength, we were able then to develop some MN domains. These were obtained from the assumption of the flat cross-section. And these are some of our results. And you can see that increasing the class of the bending strength behavior, so from a C, from a E, you are then able to cover all the demanding points. So this is something that we have observed. And these are some other diagrams. In particular, we have seen that by changing only the type of the fibers and keeping the same density, so 40 kg for cubic meter, we have observed that we were able to arrive to a bending strength of 8D. Dealing with also sustainability, we have looked at the infra-mix design and traditional mix design for the retrofitting of existing tunnels. In particular, the most important point is, okay, the quantity of cement is higher, but in this case, the cement contains also CSA, so the GWP, so the global warming potential, was not so higher compared to a traditional technique. But the most important point was the use of the steel. So for example, for the infra mix, for our mix, the steel is 40 kg for cubic meter, whereas for using ordinary steel reinforcement, we have seen that the quantity of steel required is higher than the double. So these are how we have found that quantity of steel ordinary reinforcements. So looking at the red curve, that is our mix, we have said, okay, assume that we have to guarantee the same tensile strength. We have found from this assumption, we have found the quantity of steel required, and this is the MN diagram with the other mix, and we have seen that to guarantee the same level of safety, the ordinary steel required is 90 kg for cubic meter. That is much higher, much larger than the one needed from the inframix. So these are some of the conclusions from the to conclude from the non-destructive test. It has been observed that the material is homogeneous and there are not great defects in the intersection between the layers, and the fibers are homogeneously distributed on the segments as they are not influenced by the casting. And from the destructive tests, a deflection hardening material has been obtained according to the model code 2010. And finally, compared to the steel reinforcement solution, we observed that to guarantee the same level of safety, we need the half of the steel if using steel fibers, leading also to a reduction of the CO2 emissions. So thank you for your attention.